Hello, welcome to topic 7. In this topic, we'll be looking at energy balance. So for this topic, you need to be able to describe typical energy input and typical energy output. You should be able to calculate the amount of energy available in a food. You should be able to describe the three main components of energy expenditure. Be able to describe the health risks in terms of being either underweight or being overweight, and be able to explain the various methods to assess body composition, in particular the BMI method. All right, so when we eat food and have a drink, there's energy coming in the form of carbohydrates, proteins, and fat. And if we drink alcohol, alcohol is also providing us with some calories. So these macronutrients are broken down into smaller components, whether it's glucose, amino acids, fatty acids, and then used as energy by our cells during respiration. So in the diagram, we can see the macronutrients, carbohydrates, fats, and proteins being broken down into their components, whether it's glucose, fatty acids, amino acids, and some of these small components are then used to provide energy for our cells. So the energy stored in food we can measure as kilojoules. So a gram of carbohydrates giving us 17 kilojoules, a gram of protein, again 17 kilojoules. The fat is most energy dense, that's giving us 37 kilojoules per gram. And although alcohol is not a nutrient, it's also providing us calories in the form of 29 kilojoules. So here we can see how energy dense fat is. It's providing us more than twice the amount of energy available in a carbohydrate or a protein. If we know how much of a food is being consumed, we can actually work out how much energy is being provided by doing a simple calculation. So in this example, we've got a slice of bread and some peanut butter. So we know that this food has provided us with 16 grams of carbohydrate. So the carbohydrate is giving us 17 kilojoules. So 16 times the 17 gives us 272. The meal also provided us with 7 grams of protein. So 7 times the 17 gives us 119. And we've also obtained 9 grams of fat. Multiply that by 37 and that gives us 333. So that gives us a total of 724 kilojoules from this meal. And we can actually work out the percentage fat. So percentage fat is now 46. Okay, percentage fat is just simply the kilojoules from the fat, 333, divided by the total kilojoules, 724. Here's another example, this time using the cheeseburger. So again, we need to know the amount in grams for each of the macronutrients, carbohydrates, protein, and fat. So in this example, in the cheeseburger, we know it's giving us 25.1 grams of carbohydrate, 14.7 grams of protein, 13.4 grams of fat. We multiply by the amount of energy stored in each of those macronutrients, do our calculations, and we can work out the total number of kilojoules or total amount of energy provided by this particular meal, being the cheeseburger. Okay, according to the Department of Health, a female adult should be consuming between 9,600 to 10,200 kilojoules per day, and a male should be consuming between 11,000 to 11,700 kilojoules per day. Now, a range is provided because people are various heights, various weights, and are involved in various levels of physical activity. So in this table, we can see that a person that's very active could require a lot more energy, up to 16,900, compared to a person that's very inactive. They would only require maybe 9,000 kilojoules. The graph also shows that as we get older, we need less energy. So we compare a 19-year-old, say needing 9,000 kilojoules. A person that's over 70 would only need 6,300 kilojoules. This drop in energy requirements is related to the loss of lean muscle mass. So here we can see a similar range for females. A very active female need a lot more energy, less active need a lot less energy. And again, as the female gets older, she's going to need less energy, as they're losing muscle mass. So in the previous table, we saw how the effect of age affected the amount of energy that we needed, also whether you're male or female. In terms of that, if you're males tend to be larger and tend to have more lean muscle mass than females. So as a general rule, males will actually require more energy than females. And we saw that in the previous couple of tables. Another important factor is physical activity. So the more physically active we are, the more energy that we're going to require. So at the bottom here, we've got a range of different individuals, different ages, different sex. So we've got a range of different energy requirements. When you get a chance, please view this video on what is a calorie. So the video will describe how we measure energy and how the energy is actually used in our bodies. Okay, in terms of energy expenditure, different people are going to need a different amount of energy depending on factors such as what we call the basal metabolic rate, or the energy that we need to stay alive. I think it's called the thermal effect of food. So we actually need energy to digest the food. So particularly things like proteins are a little bit more difficult to digest than other foods. Our level of physical activity. We saw previously how age affects our energy requirements. As we get older, we need less energy. Our sex also affects energy. So we see that the males actually need more energy because they tend to be bigger than females, and our body size. So a person that's taller or bigger will actually have more lean muscle mass and will actually need more energy. So in terms of energy expenditure, we've got three main components. That's the basal metabolic rate, thermal effect of food, and physical activity. So for our energy expenditure, we can see here that the basal metabolic rate accounts for 75% of our energy requirements. That's simply just basically to stay alive. We can also see here that the physical activity is the most variable, ranging from 15% to 35%. So we've got some people are very inactive and some people are very active. And there's a little bit of a range in the thermal effect of food. So some foods are quite easy to digest, like fats and sugar, and other foods are more difficult to digest, such as the proteins. So we can see here the basal metabolic rate refers to the energy required simply just staying alive, breathing, circulating your blood, maintaining body temperature, producing new cells. And people with a higher lean muscle mass will actually have a higher basal metabolic rate. And up to 75% of our total energy expenditure is basal metabolic rate. All right, so the main factor that determines your basal metabolic rate is the amount of lean muscle mass that you've got. So the greater the lean muscle mass that you have, the greater your basal metabolic rate. So if you're an older person, a smaller person, or a female, you'll tend to have less lean muscle mass, and so that'll mean that you'll have a lower basal metabolic rate. We've got some diagrams showing individuals with different levels of lean muscle mass. So this person's got less lean muscle mass, so they'll have a lower basal metabolic rate. This person's got a higher lean muscle mass, so they'll have a higher basal metabolic rate. Again, lean muscle, higher BMI. This one's got a lower lean muscle, so they'll have a lower BMR. Okay, the second component for our energy expenditure is what's called the thermal effect of food. So it actually requires some energy for us to break down those macronutrients. And in terms of the macronutrients, we can see that it's the proteins that are most difficult to digest. So they're going to require more energy than breaking down carbohydrate or breaking down the proteins. Now, third component is the energy required for physical activity. Okay, this is the most variable, as we said before. Some people are very inactive, some people are very active. Okay, so ideally what we want is a balanced situation. So we've got the energy coming in, all the various macronutrients coming in, and we've got the energy coming out, the basal metabolic rate, thermal effect of food, and physical activity. So ideally, the amount of food coming in, your BMR, physical activity, and thermal effect would actually be in balance. Okay, if it's not in balance, If you're consuming too much food, obviously you're going to put on weight. If you're not consuming enough food, you might actually become underweight. All right, so if we want to maintain a healthy body weight, what we should have is the amount of energy coming in is equivalent to the amount of energy going out. Your body can use energy provided by the food or energy it might already have in storage as body fat. All right, so to maintain energy balance, to maintain your current weight, what you need to do is make sure that the energy coming in equates to the energy going out. So really it's about not consuming too many calories and having the appropriate amount of physical activity. So if it's out of balance, having too much food, too much energy coming in, and not enough physical activity, well then you're going to start to gain some weight. Or if you're on a diet and at the same time being quite physically active, that's going to result in you losing some weight. So if you're in positive energy balance, if the food is providing you more energy than you actually need, well, over time, you're going to start putting on weight. You might become overweight, or you might even become obese. And if you're in negative energy balance, it means that you're not consuming enough food for your needs, and over time, you could start to become underweight. So across the world, we can see there are millions of people that are underweight, so negative energy balance, and we've got billions of people that are overweight or obese or positive energy balance. Now, being out of energy balance, either negative energy balance or positive energy balance, does have health consequences. So we've got 36 million people dying as a result of negative energy balance, so not enough food being consumed. And almost a similar number, 29 million people, 29 million deaths as a result of people consuming too much food and being in positive energy balance. So this map is showing some places around the world that are in positive energy balance, so consuming too much food, resulting in obesity. So places like the United States, New Zealand, Middle East, also Australia have got a large percentage of people that are overweight and also obese. And this map is showing us people that are in negative energy balance, not able to consume sufficient amount of food. So some places in Africa, some places in India, for example. Okay, when you've got time, you can please have a look at the video on energy balance, which discusses energy coming in and energy going out, and how to maintain a healthy body weight. Here are some of the reasons why populations are in positive energy balance. So in Australia, we've got about 60% of the people are overweight and about 30% of the people are actually obese. So the problem is we've got too much energy coming in. So the energy in the form of food, so we've got greater choice in food. Food is easily available as processed food or takeaway food. And the food that we're consuming tends to be very energy dense. And also the portion sizes are quite large. So we've got too much energy coming in. And at the same time, we've got reduced physical activity. So we've got people playing less sports, children playing more computer games, people walking less, using their cars, and even work tends to be less physically active. In this example at the bottom, you can see if you increase your food intake by only 130 calories, and that might be just one chocolate biscuit per day. If you do that per day over a year, you'd end up gaining 6.5 kilograms. On this chart here, we can see Australia. Australia's often within the top 10 countries that are obese or overweight. So again, here we're seeing Australia again in the top 10 of countries that are in positive energy balance that are in fact quite obese. Okay, there's significant health risks in being in positive energy balance, in being either overweight or obese. So you can see a significant risk of death as people become more and more obese. There's also a bit of a risk in being underweight as well. So here's a list of the many health problems associated with being overweight or obese. So significant health or chronic diseases such as cardiovascular disease, type 2 diabetes, some types of cancer, plus many other health problems. Although not quite as risky, being underweight can also cause health problems. So problems such as osteoporosis, being infertile, and having some sort of heart problems. There's a number of ways we can check on our energy balance, whether we're showing the correct body composition and maintaining a healthy weight. We can use things like body mass index, underwater weighing, skin fold measurements, bioelectric impedance measurements, near infrared, dual energy X-rays, and biopods. Okay, one of the easiest ways to determine whether you're maintaining a healthy weight is to use what's called body mass index. Now, there are different charts for BMI. So there are charts for adults, but there are separate BMI charts for children as well. So you need to make sure you're using the appropriate BMI charts. So according to the World Health Organization, we should be aiming for a body mass index of between 18.5 to 24.9. And that gives us a healthy weight, which would mean no increase in the risk of death. Okay, we need to be concerned when our BMI goes above 30, particularly when it goes above 35, to class 2 obesity, because then we're significantly increasing the risk of death as a result of our weight. So in green here, we've got examples of people that are in the normal body mass index range between 18.5 to 24.9. And then we've got some examples of people that are class 1 obese and class 2 obese above 35. In orange, we've got people that are classified as underweight, less than 18.5. To calculate your body mass index, you need to know the person's height, person's weight, and then we can either use a table such as this one provided here, or we can do a calculation. To calculate body mass index, you need to know the person's height in meters. You multiply the height by the height. And then in step 2, you need to know the weight of the person. And then the formula is body mass index equals the weight of the person divided by the square root of the height of the person. So if we look at a body mass index example, we'll calculate it for this person, Ruth. Her height is 1.63 meters and she weighs 78 kilograms. So to work out the BMI, we use the formula. BMI is the weight divided by the height squared. So we know that the weight is 78 kilos. We know that the height is 1.63. So it's 1.63 times 1.63. And then put 78 kilos over the top. So the BMI ends up being 29.4. And that means that Ruth is actually classified as being overweight. So some of the advantages of doing body mass index is very cheap, very easy to do. You can either use the charts or do a quick calculation. It relates pretty well with some of the other methods that we use to work out body mass and body composition, and quickly tells us whether we're in the danger zone or if we're above that body mass index of 30 to 35. It's going to increase the risk of disease. So it's a good tool to use at a population level. Now, some of the disadvantages of using BMI is it doesn't really tell you exactly where the fat is being distributed in the person. You need to make sure you're using the right charts because it's, you need the appropriate charts for children or various populations. And we can't really use it for athletes because we've seen this worked example at the bottom here. We've got a muscular athlete who's not very tall, and we've got a person here that's overweight. And if you do the calculations, they both end up with the same body mass index, even though when we look at the lean muscle mass, obviously the athlete's going to have a lot more lean muscle mass and a lot less body fat. So we really can't use BMI for muscular athletes because it'll give us an incorrect result. So BMI is useful, but it doesn't really tell us a lot about distribution of the fat. So we really need a system of working out distribution of fat and working out the total body composition. So rather than just using just BMI, we also need to think about where the fat is actually being distributed. Is the person showing an apple-shaped fat distribution, such as this example? This often happens in males, and males tend to store a lot of visceral fat, and that's going to be a problem because it's around our internal organs. Having this apple shape will increase our chances of chronic disease such as heart disease, stroke, diabetes, hypertension. The pear-shaped fat distribution is not as dangerous, and this fat distribution is normally around the backside and around the thighs, and less visceral fat around the internal organ. As there's less visceral fat around the internal organs, there's less chance of chronic disease. So here's some examples of apple-shaped fat distribution. So this is particularly dangerous, a lot of fat around the internal organs. An example of pear-shaped, so a lot of the fat's being distributed around the legs and the backside, not quite as dangerous. So here's that apple shape with lots of visceral fat surrounding all of those internal organs. So it's going to cause organ damage, fatty liver, and eventually this is going to lead to those chronic diseases like the heart disease, stroke, hypertension, diabetes. So using something like the waist circumference will actually tell us about where the fat is actually being distributed. Is the person, showing that apple-shaped fat distribution, which can actually lead to chronic disease? So the numbers we're looking at is for men, it needs to be less than 102 centimeters, and for women, we're looking at less than 88 centimeters. Okay, so to measure the waist circumference, you're normally in that relaxed position, and it's normally just around where your belly button is. So health professionals now recommend we look at both the body mass index and waist circumference as an indicator of the potential for chronic disease. So in this example, if you're within a normal BMI, 18.5 to 24.9, and at the same time showed normal waist circumference, well, then there's no increased risk. However, if your body mass index is quite high in the obese range, and your waist circumference is also quite high, showing that apple shape, those two together gives a very high risk of developing a chronic disease. Okay, some other methods that can be used to determine body composition would be things such as underwater weighing. Main problem is it's quite inconvenient and quite expensive to actually do. Another method is bioelectrical impedance. So in this, what happens is it sends out a very small electrical pulse through the body, and then the software can actually work out your body composition. It determines the amount of lean muscle mass, the amount of body fat, the amount of bone as well, and also the water composition. Problem here is if you're somewhat dehydrated, the results that you get might not actually be accurate. There are a lot of bathroom scales now on the market with this bioelectrical impedance function, and the reliability of some of these is not quite sure. Okay, another method that can be used is skin fold tests. To do the skin fold test, ideally you need to have a person that is trained. You need to take measurements in multiple locations. You need to have a good set of calipers as well. So it's pretty easy to do once you've had a little bit of training, and pretty inexpensive. These calipers are normally less than $10. There is a problem trying to take measurements from people that are obese because it's very hard to actually get the skin folds. It's pretty hard to pinch the skin in a person that's got a BMI over 30. And two other methods that could be used would be low radiation X-ray and biopod. They can provide reasonable results, but both systems are fairly expensive.